In this next section, we're going to discuss dehydration synthesis and hydrolysis. We talked about a couple of questions back and briefly in the beginning of the last section, but we'll go into it in much more detail in this section. Polymers are formed through a process called dehydration synthesis. Two monomers combine. When they do that, a water molecule is removed and a new molecule, that polymer, the combination of the two monomers, is created. We'll illustrate this process on the next slide. This process is used to create biological polymers and also some synthetic polymers. One example is polyethylene terephthalate, PET. Dehydration synthesis reactions are a subset of condensation reactions, where a small molecule such as water, ammonia, NH3, or HCl hydrochloric acid is removed. We're going to cover this much later, but what you need to know for the purposes of what we're doing in this polymers unit is that dehydration is removing of a water molecule, and synthesis is combining of two separate parts, in this case monomers, to make a new whole. All right, here is a visual for dehydration synthesis. So remember, to dehydrate is to remove water. So we have two monomers here. We'll call one molecule 1 and the second molecule 2. The end of molecule 1 has a free hydrogen, and the end of molecule 2 has this free OH group. And if we break these bonds and reform a bond of this hydrogen to this oxygen, then we get a water molecule, right? And then what happens is this molecule, after removing this hydrogen, and this molecule, after removing this OH, combine together to form a new molecule. So that's the synthesis. So we remove water, dehydrate, combine two molecules, synthesis. We're left over with a water molecule. Let's talk more about hydrolysis now. New molecules can also be formed by breaking existing molecules apart, allowing the products to react with other molecules. This breaking apart process is called hydrolysis. So a water molecule is added to a molecule that causes the molecule to split apart into separate molecules. The H and OH groups from the water will then combine with each product, as illustrated on the next slide. So hydrolysis, if we break the word up, we get hydro, meaning water, and lysis, meaning splitting. So we're splitting a molecule with water by adding water. All right, so this diagram is actually just the reverse reaction for the dehydration synthesis that we saw about 2 slides back. We have this original molecule here, and we're going to add water at this bond right here to lyse it or break it. And what we'll end up with is 2 molecules, one that contains that H from the water and the other that contains the OH from the water. So adding a water molecule, which is the hydro, splits the original molecule into 2 new molecules, the lysing or lysis process. On this slide, we just show another way to visualize the dehydration synthesis and hydrolysis processes. So in dehydration synthesis, remember that synthesis here is the word, right? So the synthesis is the word. Synthesis is bringing together or making something. So what we do is we bring together 2 monomers And through dehydration synthesis, we create a polymer, and we have the water that we removed as a product. Then the reverse process is this hydrolysis, and remember, lysis is our key there. We're using water to lyse or break a polymer. So if we take a polymer and we add water to it, we can break the polymer up into two monomers as our products.